Try it right now. Run your fingers along your own rib. Move them the exact way a friend would if they wanted to make you scream with laughter. Nothing happens. Maybe a flinch, maybe a small embarrassed smile. But the wild, uncontrollable laughter you feel when someone else does the exact same thing, gone completely. Why? You've probably run this experiment 100 times, usually as a kid, usually right after losing a tickle fight, and wondering why you couldn't just skip the whole ordeal and do it yourself. The answer you landed on was simple. You already know it's coming. That explanation feels obvious. It's also almost completely wrong. So what is actually happening the moment your own fingers touch your own skin? Here's the reframe. Your brain isn't a passive recorder of the world. It's a forecasting machine. Every second of your life, it predicts what your body is about to feel before it feels it. Lift a coffee cup and your brain has already calculated the weight and the pressure your fingers are about to register, a fraction of a second before the signal even arrives. Strange, right? This isn't a figure of speech. It's a measurable process happening in real neural tissue, and tickling turns out to be one of the strangest windows science has ever found into watching that process work. When you try to tickle yourself, your brain isn't simply noticing your hand move, it's generating a complete forecast of the sensation that movement is about to create, then matching that forecast against the sensation as it actually arrives. What's left over once the two are compared? Almost nothing. So what happens when the forecast and the sensation don't line up at all? People have been chasing that question for more than a century. In 1897, two psychologists named G. Stanley Hall and Arthur Allen published one of the first serious scientific papers on tickling. They noticed something odd. Tickling wasn't one sensation, it was two. There was a light, crawling itch, the kind produced by a feather drawn across skin, and it made you want to scratch, not laugh. Hall and Allen called this nismesis. Then there was the other kind, heavier, more rhythmic, applied to the ribs or the underarms, producing helpless laughter instead of an itch. They called this gargalesis. Here's the detail that mattered most. Nismesis, the itchy kind, was easy to produce on yourself with nothing more than your own fingernail. Gargalesis, the laughing kind, almost never was. Why would one type of touch survive contact with your own hand, while the other vanished the moment you tried it? That 1897 paper was only the beginning of how strange this story gets. Decades later, a neuroscientist named Jaak Panksepp, working at Bowling Green State University, wondered whether laughter itself might be older than language, older than humans, maybe even older than primates. So he did something that sounds almost like a joke. He tickled rats, specifically the loose skin on the back of their neck, the exact spot young rats target when they wrestle each other in play. Using recording equipment tuned to frequencies far above human hearing, Panksepp discovered the rats were chirping, not squeaking in distress. Chirping in short, high bursts around 50 kilohertz, the same ultrasonic range rats used during their most social, most playful interactions. Panksepp came to believe those chirps were a distant rodent-shaped cousin of human laughter, a signal so ancient it predates humans by tens of millions of years. If he's right, laughter didn't start with a joke, or even with a person. It may have started in a warm wrestling nest of rodents, feeling something like joy, long before anything on Earth could put that feeling into words. A clear, mechanistic answer for why you specifically can't tickle yourself didn't arrive until 1998.